Hey everybody, how's it all going? I have definitely had better days. I think one of the things that bothers me is the thing that's making today not a great day for me is unfortunately something that I'm not able to share with all of you. Because some things must remain private. Some things must remain private. They cannot simply be shared with any random person. And this is one of those things. So I apologize in advance if I'm not my usual bubbly self for this board repair video, because at this point in time I am particularly bummed and feel particularly stupid, and I realize that I just kind of earned feeling stupid, and I just have to deal with it. Realizing that you're an idiot is kind of something that you just have to grieve. You know, once you figure out that you did something stupid and you have to deal with it, it's just kind of the grieving process of, man, you're really that dumb? Alright, so what we're going to do here is figure out what's going on with this MacBook. So it's taking 12 milliamps. That's a strange number. You don't get a green light, so I'm guessing PP3V42 is gone. First thing I'm going to do is unplug everything here and see what's going on there. I'm going to unplug, and I'm going to take everything out of this machine and see what's going on with it. This is an 820-3332. So PP3V42, which is the power rail required for the one-wire circuit to work, is 3.42 volts. The one-wire circuit is what's going to give us a light in the charger. We don't have a light in the charger right now. And PPBUS G3H, the next rail, is 4 volts. Alright, so the green light can be controlled by the ISL6259, which shoots out SMC, BC, ACOK to the one-wire circuit to allow the green light to turn on. And the ISL6259 is also the chip responsible for PPBUS being 12.5 volts instead of 4 volts. So what do I mean by that? Well, that's a great question. I would suggest that you watch any of my one-wire videos to understand the one-wire circuit, so you understand what I mean with the green light on the charger. Let's take a look at that. So this is the charge port is over here, right? So this is my charger. See, it plugs in right over here. So we're going to take a look at that on the schematic in the board view. I'm going to walk you through that here. So how does this work? Well, the adapter, before it puts out 18 volts and before everything really works the way it's supposed to, what happens is adapter sends this signal, needs to speak. PP of that board is short. It says Pedro. Nah, because the PP of this board is 4 volts, so that's not a short circuit. You know what it is. I'll give you a hint, Pedro. It's eyes. When you look at it, it looks like eyes in the microscope. And I will show you that in just a moment. But so adapter sends, needs to speak to the system management controller on the sys1 wire line. Sys1 wire, if you take a look, is going to go to the SMC. See? It's a bidirectional data line to U4900, which is the system management controller, SMC. Now, in order for this chip to do its job and allow the adapter sends to speak to the SMC, this chip needs to be on. For this chip to be on, it needs to be getting power, VCC pin. This chip to get power, this logic gate needs to work. This is how it's going to pass PP3V42_G3H to U6900. And this logic gate's not going to work unless SMC, BC, ACOK is present. So I need PP3V42 to be present because this one-wire circuit, this whole circuit that allows the charger to speak to the computer, is not going to be powered if this is not there. But this also needs SMC, BC, ACOK to be present, right? So we have no green light, so this circuit's not working. Now, the next thing that I noticed is that PPBUS G3H is also not present. Okay, so SMC, BC, ACOK turns into charger ACOK, which is over here at the ISL6259. Now, the ISL6259 is responsible for PPBUS G3H, which is low. So we have two problems on the computer right now. So the first one is that we don't have a green light. And the second is that this power rail, PPBUS G3H, is 4 volts instead of its standard 12.5. So we have two problems that both come back to this same chip. So I'm not going to try to diagnose these problems separately. I'm going to look at this chip area because this is probably where my problem is. So where is U7000? Well, that's a great question. So we're going to take a look at CD3215. Or this machine doesn't even have CD3215s. Watch my videos. Anyway, so U7000 is right over here. So then when I put this under the microscope camera, what you're going to see and what I know Pedro would have known by now from watching all this stuff, I'm confident Pedro knew this before he even logged onto the stream, is that it's not a PPBUS short. Rather, it's the eyes. Does anybody see the eyes? I'm going to give you a chance before I point it out. Where are the eyes? Does anybody see the eyes? I'm going to unplug the power supply so that I can point on the board. Top two resistors. Very good, yummy steak. Now, these two resistors are supposed to be about 10 ohms each. And if we measure this in ohms mode, that ain't 10 ohms, man. That ain't 10 ohms. Now, if we were to replace those resistors, it wouldn't even matter because, as you can see over here, shorted to ground. So this over here is shorted to ground. And it's shorted to ground through the ISL 6259. So what is that area? And what is it for? Another great question. This is a current sensing circuit. So, take a look on the schematic. Let's get a big view again. Nice big view over here, schematic. This is a circuit that's going to take the 18 volts from the charger, and it's going to turn it into 12.5 volts for the system. This is how we get the battery to charge from a power adapter. The power adapter provides 18.5 volts. The battery is going to be charged at 12.56 volts, and that's how this works. So, this over here, this is a transistor that's going to keep reverse current from going through. So let's say that my battery is plugged in and it sees my charger as a load. You don't want the battery to be able to go up through here and charge the charger. That's ridiculous. I don't know if any of you have ever had a really cheap 18650 charger where when you plug it in to the wall with the 18650, the light turns red to tell you it's charging. But then when you unplug it from the wall and install the battery in there, the light is still on because there's no reverse current protection. So the battery is then, quote, charging the charger. It's ridiculous. So this is there to keep that from happening. Then you have this. This is a current sense resistor. So this chip is responsible for creating this power rail over here. But it wants to know how much current is this using. But this chip is out of the stream, so it can't tell. It's kind of like you trying to tell how hard water is flowing without your hands in the stream. You would need your hand in the stream to be able to measure. The same thing with the chip. It's not in the stream. So this is where the current is going to be going through, because it goes out here and then turns into 12.5 volts. So this is going to be 18 volts coming through here. This is a transistor. It's going to turn, it's like a switch. It turns on, off, on, off, on, off. 18, 0, 18, 0, 18, 0. That's going to get evened out into 12.5 volts when it goes through this coil. The combination of a pulse of 18 and then 0, and then 18 and then 0. This chip controls that happening. Now it's going to want to know how much current is going through it, but it can't because it's not in the stream. So what it does is it's going to put its hands in the stream, or in this case, it's going to put a resistor there. Now this resistor is going to have a different voltage at the top and the bottom, and that voltage difference is going to be proportional to the amount of current that is going through. So let's say that the system is taking thousands of amps. You're probably going to, I'm just making shit up here, but like if it was thousands of amps, maybe you have 18 volts up here and 15 volts down here. Whereas if it was only taking a quarter of an amp, you have 18 volts up here and 17.99999 volts down here. And the ISL 6259 is going to check the voltage at the top or the bottom, and then it's going to determine how much amperage the system is using. And it has this 10 ohm resistor in between. Now, the 10 ohm resistor in between is dead. And when I checked on this end of the resistor, it was short-circuited to ground, which means our U7000 or ISL 6259 was destroyed. So what we're going to do here to fix it is I'm not just going to replace the resistors, because replacing the resistors is going to result in them blowing immediately right after I'm done, because the ISL 6259 is also shorted to ground. We are going to replace those two resistors, but also replace the ISL 6259 that failed in this manner. Maybe I should put some more flux. I hope your business is doing well, Pedro. I hope you're doing well as well. I'll check it out, Nitrocaster. Thanks for the suggestion of that app. Alright, so I'm just going to heat this up. Iced Tea Junkie, the question there is, how long did it take you to get to a skill of intuition and pinpointing problems that it became commercially viable? A really long time, because I'm not very smart. Yeah, a really long time. Like I set out to start doing this in 2009. It wasn't even until like 2011 that I had replaced a backlight fuse. Yeah, that's like that's really shitty. And then there's the. It wasn't until like 2014 that I was good enough to do even the more difficult ones in house. That was like late. So like it's a long time. And again, when you look at it, even my worst students actually learned it much quicker than I did because I'm not very smart. But what I make up for in not being smart, I think I make up for the not being smart by simply choosing to focus on it at the expense of many other things until I learned it. Like what I lacked in intelligence, I just kind of made up for, and I don't really have a problem experimenting until 4 in the morning every single day and failing over and over and over again and feeling really stupid because I failed over and over and over again and fail, almost want to cry, fail again, almost want to cry again, keep doing it, and then someday, you got something. Okay, you got a teeny tiny thing. You barely got even anything, but that's more than nothing. Look, improvement. And then that's the encouragement to try again. And again. And again. And again. And one of the things that I try to do here is I try to kind of go through the issues and share it, because it would be cool if other people were able to take part in the thing that I enjoy and that I find fun and that I was able to eventually learn for myself. But yeah, it took me a really long time. It took an embarrassingly long amount of time. But it's fun to be good at something. I'll say that. Like, it's fun to be good enough at something that you can just figure out and pinpoint things and know it like the back of your hands and be able to use that skill to... I really wanted to make the most of this. Like, if I put all that time and effort into figuring this out in an idiot-proof way so that a dumbass could figure it out, I really wanted to make sure that I got the most of it. Like, how many other people can we get to bypass the experience Lewis had of feeling like a moron for years and years and years because none of it makes sense? Still got a long way to go there. Alright, so... Gonna give this a little bit of rapid cooling. Rapid cool! Rapid cool is my patent. We are stuck at the same 18 milliamps. Alright, I should have maybe made some more cursory measurements first before I got too excited. Maybe I should share them with you. 21 ohms in current sensing, that's exactly what that's supposed to be there. This current sensing here is exactly what that's supposed to be here. $18 volts is going through there. 18 volts is going to charger DC in. Okay, we're just going to follow this back then. So, let's figure it out. They're different chips, Manicron. It's just SMC is a system management controller, and the U7100 is it controls makes PPBUS G3 hot. So they're just totally different chips with totally different points. I feel you about the lack of raw intelligence. I'm not especially smart and was broke for more than a decade and a half before I had the weight. I'm actually good at this moment and found a job in software. Keep being you. Thank you. I'm glad to hear it. Glad to hear you got somewhere. All right, so PPBUS is 12.5 volts. So at this point, I think I'm just being trolled. So 12.5 volts means the SMC is doing its job. Because PPBUS G3 hot would be 12.23 if the SMC was communicating something less. So now we're going to take a look at the one-wire circuit area. It's going to be these two little bastards down here. You're smarter than me if you got a job in software. Adapter sense and sys1 wire. So pin 5 and pin 4. We're going to check out pin 5 and pin 4. Because that's going to tell me what's coming in from the charger. Now usually adapter sense when the DC inboard is good is 3 volts. That's 0.7. That's bad. That's not good. 0.7. So that could be a bad DC inboard as well. So it's very possible that the charging port is fried and it's not actually passing through what's needed for my MagSafe. So I'm going to go and grab another DC inboard. I'll be right back. I'm going to take a trip over to the other side of the store. It's actually far enough away now that I can call it a trip. Like I actually have to make a trip to get a DC inboard. Okay, this is my test charge port, and as you can see, now we are getting it to take an amp, which is correct. And if I were to measure voltage, you'd see the adapter sense is a proper amount. Adapter sense is now 3.3 volts. Sys1 wire is 3.3 volts, which is what I'm expecting it to be. On the schematic, you would see, so when the bad charger went through, it actually killed my DC inboard, so it was only sending 0.7 volts in adapter sense rather than 3.3. Likely wasn't able to communicate anymore. So the bad charger that was plugged into this machine destroyed not only the charge port, but it also killed the charging regulator chip, U7000. It killed its current sensing circuit and shorted that. This wound up getting shorted to ground. Yeah, this over here wound up getting shorted to ground. Pins 28 and 27. And these resistors in the current sense circuit died. But now it works. It has a spinning fan. It'll be able to charge a battery. And that just does kind of suck. That a bad charger can cause all of this. A little bit of money saved on the charger can cause a lot of money to have to be spent on the fixing of the rest of the computer when that dies. And just because I'm a nice guy, and I realize this is going to be back here in a week, if not less, with crashing GPU problems, because this is a 2012, early 2013 Retina, I am going to reflow his U8900, because if I don't reflow this, it will be back here crashing in less than a week. I know it. So just you can see that from several of my videos about the 820-3332 board. Had a little Apple recall that didn't last for long. You didn't get it fixed by 2016, you weren't eligible. And even if you did have it fixed by 2016, well, you still, it would have broke again. Let's be real here. We're going to do a little bit of mild reflow over there. And when we do that mild reflow, we're going to make sure that we use the appropriate amount of flux. There is a fuse on the charger line, Mani Katan. There is a fuse. Does anybody know what the right amount of flux is? Yummy Steaks is paying attention. I'm noticing that in the chat that Yummy Steak is paying a lot of attention and getting a lot of right answers. Yummy Steak, are you in the business or do you just watch a lot of my videos because you don't have much else to do? I'm curious. Nice try, little bridge. I'm sorry to hear that. I hope that you were able to make a full recovery, and I hope that you're feeling better. I'm glad to hear that you learned something from watching all these videos. If you don't have a job, and you want to live in the absolute garbage hole dump that is New York City, keep me in mind. You seem to know your stuff, and you seem to be able to answer my questions very, very quickly, and you seem to be good at predicting what's wrong with the board. At this point, the motherboard is going to be ultrasonically cleaned. The machine will be reassembled, and then it will be tested to ensure that every other function works. But that's a process that I do off video because it's highly boring to most people. So you got to watch a video where I fix the board, and hopefully from that video you were able to learn something. If you were able to learn something, then I'm very happy, and I hope that you continue to watch and continue to learn. I'm sorry that I haven't had as much time recently to do these videos as I have in the past, when I would release board repair videos on a much more regular schedule. I've made some interesting life choices and some interesting business choices that have really kind of deprived me of much of the time that I used to allocate to those things, and it's resulted in less of that stuff being produced, which I'm not particularly happy about, but I don't know, I feel like I'm a bit existentialist in that when there's an opportunity, I think there's an opportunity, I kind of just ride with it and see where it takes me. And I've been doing that for a long time. Some days I'm happy about it. Some days I'm not so happy about it, like when I started the stream. But we'll see what the rest of the year holds in store for me and what the future holds in store for me. And we'll see what the future holds in store for all of you. Hopefully more fixed and working MacBooks, more happy customers, people with their data back, people with machines that work, and people who can have that little yes feeling when they see that the fan spins and the light turns on and everything works. That beautiful feeling of accomplishment that is particularly unique to component level board repair industry that we're in. That's it for today, and as always, I hope you learned something. I'll see you all in the next video. Bye now. See you later.